Okay, for the next part of our geometry review, we will review the bottom section of this sheet, the angle and triangle section, and then I will do a little review of unit conversions, which is not something in your book, but I have found that it's something that a lot of people don't know how to do that you really do need to know how to do. So first of all, angles and triangles. If you go all the way around, you turn yourself in a complete circle, you do a 360. That's something that we actually use colloquially. Now, also another thing that we use just in conversation is doing a 180, an about face. You completely change direction. So if you're pointing one direction, you end up pointing the opposite direction, you do a 180. Half of 180 is 90 degrees. So those are the three common degrees that you should be very, very familiar with. Complementary angles make a corner. If you see in the sheet in that bottom section, the top left part of that bottom section, two angles are complementary if the sum of their measures is 90 degrees. So the way I remember that is complementary starts with E and C, and corner starts with C, so complementary angles make a corner. They add to 90 degrees. That's that guy right there. Supplementary angles are angles that add to 180 degrees. So supplementary angles make a straight line, S and S. It's just probably a silly way to remember it, but it works for me. Okay, angles of a triangle add to 180 degrees. So no matter what the triangle looks like, the three angles of that triangle will always be 180 degrees. We're just going to kind of mention it here. You've got a couple little things on homework, but we'll use these facts quite heavily in the story problems. So if you ever have a triangle, the angles add to 180 degrees. So name some complementary angles. Remember, complementary angles make a corner, so they have to add to 90 degrees. Well, 45 and 45, those add to 90. 30 and 60, 25 and 65, anything that you can think of. Any two numbers that add to 90, those would be complementary angles. Supplementary angles. Well, obviously 90 and 90 would make 180. 40 and 140, 60 and 120, just any two angles that add to 180 degrees. What is the complement of 42 degrees? Remember, complementary angles add to 90. So what would I need to add to 42 to get 90? Well, 90 minus 42 is 48. So 48 degrees is the complement of 42. What is the supplement of 42 degrees? Again, remember, supplementary angles add to 180. So I'd be looking for 180 minus 42, which is 138 degrees. Okay, if two angles of a triangle are 23 degrees and 47 degrees, what is the third angle? We know that if we have a triangle, no matter what, the angles will add to 180. So we'd have 180 minus 23 minus 47, that would give me 110 degrees. Okay, the angle between the bell tower of Pisa and the ground is 84 degrees, on the small side, obviously. What is the angle on the other side? Okay, so there's my straight line. There's the Leaning Tower of Pisa. So if the smaller angle is 84.5, this guy has to be 180 minus 84.5, so it's 95.5 degrees. Okay, let's say that we have a ladder leaning against the side of a building. It makes a 50-degree angle with the ground. What angle does it make with the building? What shape do you see there? Okay, we've got a triangle. So we know that guy is 50. That's a right angle. That's 90 degrees. So we do know that angle. So we have 180 minus 50 minus 90 would mean that top angle is 40 degrees. So that's just a quick review of the angles and triangles, and we will now go on to unit conversions. Okay, if you work for 3 hours and your brother works for 90 minutes, how much have you worked all together? Well, I work for 3 hours. My brother works for 1.5 hours because that's 90 minutes. So we work for 4.5 hours altogether. What did you do to find the answer? Notice with 3 and 90, there wasn't anything I could do. I had to convert them to the same units, so I converted my brother's time to hours. This is just making sure that you've got apples and apples, so you need to have the same units. It's often necessary, or at least useful, to convert the units of information that's given. Many people can just change 90 minutes to 1.5 hours in their head, but here's how to do it formally. You'd say, here's 90 minutes. I'd multiply by 1. So I'd multiply by 1 hour over 60 minutes. The reason I do that is I want the 60 minutes to, I want minutes to cancel with minutes. So I'd put minutes on the bottom, hours on the top, and 1 hour is the same thing as 60 minutes, so I'm just multiplying by 1. The reason I chose that form of 1 is I wanted the minutes to cancel and I want to end up with hours. So I'd cancel the minutes and I'd end up with 90 over 60 hours, which is just 1.5 hours. That's how I know my brother works for an hour and a half. Okay, so I'm just going to be multiplying by 1 to change my units. And my 1 is going to look like a lot of different things. I'm just going to choose a different form of 1. So whatever is on the top has to be the same as what's on the bottom so that we're not changing anything. Okay, I want to convert 273 inches to feet. So here's 273 inches. Now I want to get rid of the inches and I want to get feet. So what is the relationship between inches and feet? Well, I know that 1 foot is the same as 12 inches. So I'm going to multiply by 1 foot over 12 inches. Now, I need to pay close attention to what's on the top and what's on the bottom. I could have just as easily multiplied by 12 inches over 1 foot, but I want inches on the bottom so that they'll cancel with inches on the top. I'm always trying to cancel my units and end up with the units I want. So I'd get 273 over 12 feet, because my inches cancel, which would be 22.75 feet. Now let's say that we want to convert that many gigabytes to terabytes. Now most people will just say that 1 terabyte is 1,000 gigabytes. I understand, but I wanted to make it a little more complicated so we could see what's going on, because a terabyte technically is 1,024 gigabytes. So let's say that we have 4,652 gigabytes. Now I just told you that 1 terabyte is the same as 1,024 gigabytes. So I'm going to multiply it. That's just multiplying by 1 because those two things are equal. Why did I put gigabytes on the bottom? Okay, I put gigabytes on the bottom so they'd cancel with the gigabytes on the top and I'd be left with terabytes. So my numbers would be 4,652 over 1,024. My gigabytes cancel. I'm just left with terabytes. So I'd have 5.54 terabytes. How many minutes are in 3.5 years? Well, here's my 3.5 years. Now, most people can't tell me right now what the relationship between years and minutes are. And that's fine. That's totally fine. But we do know the relationship between years and days. We could say 1 year is the same as 365 days. So that gets us one step closer. We'd put years on the bottom because I want years to cancel with the years on the top. And that would leave me with days, but I don't want days. I want minutes. Now, I don't know a relationship between days and minutes, but I do know a relationship between days and hours. 1 day is equal to 24 hours. So that set of parentheses is just equal to 1. The only thing it's doing is changing my units. 1 day is the same as 24 hours. I put day on the bottom and hour on top so that my days would cancel. And lastly, 1 hour is the same as 60 minutes. My hours would cancel. I am left with minutes. So all my numbers would be 3.5 times 365 times 24 times 60. Years cancel with years. Days cancel with days. Hours cancel with hours. And the only units left over are minutes. So I get 1,839,600 minutes. Okay, next, convert 42 feet to meters. Here's 42 feet. Now I've given you some relationships. In the homework I give you a lot of relationships to use. I want to get rid of my feet, but I don't have a relationship between feet and meters. But I do with centimeters, so let's change it to centimeters first. I put feet on the bottom to cancel with the feet on the top. And if I just multiply this, I'll end up with centimeters, but I don't want to end up with centimeters. I want to end up with meters, so let me do another multiplication. Again, I'm just multiplying by 1. 1 meter is exactly the same as 100 centimeters. The reason I'm multiplying is so that I can cancel my centimeters. Now if I do my multiplication, I'll have 42 times 30.48 divided by 100, that's the number part. Feet cancels with feet, centimeters cancels with centimeters, and I'm just left with meters, so I have 12.8 meters. Okay, here are some final examples. These ones are slightly more complicated, but I know you can get them. We have 65 miles per hour. This one's an easy conversion, but I want you to get used to these with two kind of more complicated units. So this is 65 miles per hour. See the hour on the bottom. I want to convert it to kilometers per hour, and I know that 1 mile is the same as 1.609344 kilometers. So I'm going to multiply by the kilometer over the mile. That's just multiplying by 1 because those two are equal. The reason I put the kilometers on top is I want my miles to cancel with my miles. So that would give me 65 times 1.609344. The miles cancel and I have kilometers, and I still have hours on the bottom, so I have kilometers per hour. Okay, let's do one a little more involved. This looks really impressive, but it's actually easy. Just watch. We have 12 miles per hour, and I want to end up with meters per second. So I'm going to say, okay, I know how to turn it into kilometers. I've already done that. Now 1 kilometer is the same as 1,000 meters. Notice my kilometers was on top in the first set of parentheses. That turned it into kilometers. Now I want to turn it out of kilometers and into meters, so my kilometer is on the bottom. Now if you look at the units, miles cancel with miles, kilometers cancel with kilometers, and I have meters per hour. I don't want meters per hour, I want meters per second. Well, how do we turn hours into seconds? We know that 1 hour is equal to 60 minutes. Now here my hour is on the top. Why do I have the hour on the top? Good, I have the hour on the top because the hour is on the bottom in the very first thing, that 12 miles per hour. So I put hour on the top so that those hours would cancel. I have minutes, I don't want minutes, I want seconds, so I put 1 minute on the top, 60 seconds on the bottom. Now I've got a whole bunch of numbers there. Miles cancel with miles, kilometers cancel with kilometers, hours cancel with hours, minutes cancel with minutes. Multiply and divide all the numbers together, and I have 5.36, and the only units left over are meters per second. Okay, next, do these next 3. Pause the video and do these all on your own. Okay, now that you've got them done, 0.3 years to seconds. Here's my 0.3 years. Now I don't know how to get to seconds, but I know how to get to days. Years go on the bottom to cancel with years. Now that I've got days, I can get hours. I want my days to cancel. 1 day is equal to 24 hours. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So after I cancel out all those units, I'm just left with 9,460,800 seconds. Okay, the speed limit of that highway in British Columbia is 110 kilometers per hour. What is the equivalent speed in miles per hour? Okay, now I know that 1 mile is 1.609344 kilometers. This time kilometers is on the bottom. Why? Okay, good. It's on the bottom because it's on the top in that first thing. I need those units to cancel. 1 mile is equal to 1.609344 kilometers. I've just multiplied by 1 in that set of parentheses, but I put the kilometers on the bottom so that they'll cancel and I'll get the units I want. So that gives me miles per hour, 68.4 miles per hour. Okay, last example. The speed of the snail is 0.001 meters per second. What is it in miles per hour? On this one, you're going to have to convert both the time and the distance. So let's do distance first. 1,000 meters is the same as 1 kilometer. 1 mile is the same as 1.609344 kilometers. That gets me my distance. That gets me miles. Now I need to turn seconds into hours. 60 seconds is 1 minute. I need 6 seconds on the top to cancel with seconds on the bottom. 60 minutes is 1 hour. So it comes out to 0.0022 miles per hour. Good job. That is how you convert units.